Okay, so let's start with the second lecture. So this is the main discussion now, because I think in lecture number one is what you did there is mostly you read the topic, the context of the introduction of this course. So in this topic, we'll be going to the resultant, the concurrence and components of forces and moments. So it's more like of a physics subject, yeah. So forces, we know that from physics. So still forces in statics of rigid bodies. But for moments, so in physics term, so this one is torque in physics. So in engineering courses, so instead of mentioning torque, so we label it as moment. So that's force times the distance, perpendicular distance. So the same concept as the torque. All right. Okay, so force is characterized by the following. So we have the magnitude, meaning the it could be a huge amount of force or a small amount of force. Then since force is a vector, so of course there's a direction. So as what you have read from the first lecture, so we have scalar and vector components. So scalar are those with magnitude only without direction, and vector is magnitude plus direction. Then of course it's very important in statics of rigid bodies, the point of application of your force. So for example, when you reach your higher design subjects, so for example reinforced concrete, especially when you design buildings, so the point of application of your columns, of your slab, of your beams are important. So that's why, because it has an effect on the system. Okay, so it could be eccentric, non-eccentric, concentric, concentric. So muna siyang different application of your forces. Okay, so as you can see in the diagram, so the force may be on the left part of this block here. So if we try to apply the moment or the torque, so possibly it can rotate counterclockwise depending on the magnitude of the force. Then for example here on the second figure, let's say your point of application of your force is in this direction. So you may be able to push this box forward. And let's say we transfer the point of application upwards, let's say this in this direction. So there's a chance that you can push the box forward, or there's a chance that you can topple the box over, or you have a torque, counterclockwise torque. Right? So depending on the magnitude. So that's what we need to analyze in statics of rigid bodies. So the behavior of your system upon the application of your forces. Okay, so in forces, so again, forces are vectors. So for example, in one point of application, so there are many forces to be considered. So let's say you have a column here. So do you know a column, right? Column, haligi, ano? Okay, so let's say your column has a vertical load, vertical downward load, and let's say horizontal load as well. Let's say produced by earthquake. So of course, the forces does not apply the rules of addition, because to add up the resultant, so you may know this from physics. So to add the resultant, so you need to use a particular technique, but you cannot just add them up since this one is vertical, then this one is horizontal. So you cannot add two different forces having different direction, but you can add forces having the same direction. Okay. So of course, if you want to add up or you want to summarize your forces, so that's what we call as your resultant force. Okay, this green line here. But again, the value of which is not 5 because we cannot add them directly. We need a special technique for this particular resultant force. And again, it will depend on the drawing of your force diagram. Right? So this is just a reminder for those who forgot their physics concept. So again, we cannot add forces, but we need to solve your resultant force through a specific um, process or computation in in your trigo. So it could be sine law, it could be cosine law, it could be Pythagorean theorem, as long as it's not addition. Okay. Okay. So again, forces are drawn as directed arrows. So the length of the arrow represents the magnitude of the force, and the arrow shows its direction. So in most cases, since we're not very strict in physics part, so in most of our drawings is you'll probably be estimating the length of your force. So for example, we're going to have a force triangle of, let's say this one is 5 kilonewtons, then this one is 10. So of course, it's it's better that we make the 10 kilonewtons longer compared to 5 kilonewtons. Kay murag batit sa tanaw no, if let's say this is 5 kilonewtons and then this one is your 10 kilonewtons, so it doesn't justify the values being presented in your diagram. So for this one to be valid, so of course the 10 kilonewtons should be longer than the 5 kilonewtons. So it may not be the correct length, let's say upon drawing, but at least you justified it in your drawing that 10 kilonewtons is bigger than 5 kilonewtons because it has a longer length sa inyong arrow. Okay, then we also have the line of action. So the line of action is important later on when we deal with force systems. But for now, we'll be understanding the concept of your forces first. So basics are basics. Okay, so in your forces, so if you want to get the resultant force, so there's what we call as the parallelogram law, parallelogram of vector addition. So your R is the resultant force, then your P and your Q are your components. Okay, so R is the resultant, so that's why it's R resultant. And then P and Q are components of your resultant. So in the equation on the right side, you have R is equal to P plus Q. So this one means that when we add up the two forces, it results to the R value. But again, since we cannot add up the values of your forces, so again, this is just a visual representation that when you combine P and Q, it results to the R force being presented in the diagram as a green line. So again, what we will be doing here, since we are going to use the parallelogram law, murag ko ano, murag kanang tongue twister. So again, if we use this law, parallelogram, this is what I pronounce it. Diba? If we use this law, so what we'll be dealing here is to get the resultant is we'll be using the sine law. So that will be for later. So why sine law? Because again, as you can see here in the hidden line, so we can transfer Q on this right side. I mean on the top side. Diba? Then we can work on this triangle here. So once we know the angles for the different sides, so we can use the sine law to solve for the resultant force. So this one is sine law because this is not a right triangle. So if it's a right triangle, so we'll be using the Pythagorean theorem. Okay. Okay, so this one is, I think you can just read this one. So two vectors are equal if they have the same magnitude and direction. So it's very self-explanatory. So let's say F and then F prime has the same magnitude and direction, so meaning they are equal. So also if we have a negative force, so we denote it as negative F. Okay, so usually in civil engineering, so what we usually term our forces is if we go up, so that's a positive force. When we go down, that's negative force. When we go right, that's positive. When we go left, that's negative. Then for the torque or for the moment, if we have clockwise, that's positive. If we have counterclockwise, that's negative. So that's what we term our forces in engineering. So everything that is going up is positive. Everything that is going down, regardless if it's diagonally going downward, so that's still negative. Okay, so for example, in this manner, so for example, this F here, so this one is positive F prime because if we break the components into two different forces, so you'll have a force going to the right, you have a force going upward. Okay, so that's how we deal with forces later on. Okay, so in vector addition, we have the commutative property. So regardless of you have P plus Q or Q plus P, so that's all right as long as you get the correct resultant force. Okay, so this one is a bit old school. So this diagram here is a bit old school, but what we learn from physics is we connect our component forces, then we create the resultant force. So for example, here you have P and Q. So we had, I think the popular term here is instead of tip to tail. So I think the term in your physics before, or in, I think in most physics class is head to tail. Okay, head to tail na siya. So from one head of the force going to the tail of the second force. So for example, this P here. So again, head to tail. Okay, then head to tail. And then once you have those two forces being together, the force components. So that's the time that you will be drawing the resultant force. Okay, so R, P, and Q. So draw first the force components, then after drawing the force components using the head to tail technique, then you create the resultant force. So again, it's in your own discretion whether you want to put P first and then add or connect Q, or Q first here, as you can see in the first diagram, then connect P. So in the second diagram, that's P first, then connect Q. So that's why we have the commutative property in your vector addition. So P plus Q is still equivalent to Q plus P, and it will still result to the same resultant. Alright? So, mora na siya review jud sa inyong physics. Okay, so what if we have multiple vectors? So let's say more than two forces na. So I think it's a bit advanced na, di ba? Or a bit kanang complicated. So it's still the same, but of course, you'll be just adding up the forces. So for example, in this diagram, so you're still going to use the head to tail or the tip to tail technique. So again, if you don't want this type of diagram, so what you need to do is you add up the different forces. So let's say this one is S, and this one is P, and then this one is sorry, so let's say this one is S, this one is P, then this one is Q. So notice that the direction of the resultant force is most likely the same as the given diagram. So marag di lang siya drawn to scale, no? So this one is the resultant. So this one is Q, this one is P, this one is S. Okay. So most likely if you're going to add up multiple vectors, so we may not be able to use the different triangular methods. Let's say the sine law and the cosine law, since you'll be having a what do you call this one, a kaning magdi na siya kanang triangle, di ba? So more likely a trapezoid or an irregular trapezoid. So muna siya inyong isolve. Kuan siya, it's a quadrilateral. Okay, so you need another method in solving this particular system. Okay, so from so aside from adding it from tip to tail, so going back to the property of vector addition, so it doesn't matter if you add up the two vectors first, and then you add the third vector, it will still result to the the R value, the resultant of your force system. Okay, so it doesn't matter if you add up P plus Q first and then add S later, or add S and P first then add Q later, or S plus Q first and then add P after. So it will still result to R. So again, the vector addition is again in the first few slides. So it was stated there that you cannot add up directly your vectors. So we need a special computation for that one, which will be tackled later. So we just represent your vector addition as plus plus. But again, so for example, this one is 1, this one is 1, this one is 2. So your R is not equal to 4. So it may be presented in this manner, but again, the process or the computation for your resultant force is not direct addition, but there's a special process, let's say cosine law, sine law, and okay. Okay, so I think it's the same as the previous slide. So associative property. Okay, so I think this is what I meant earlier. So from tip to tail rule, or the head to tail rule, head to tail. So in some books, it's called the Polygon Law, because if you are dealing with more than three forces, so you might end up creating a polygon. So example of this one is this figure. So if you have three forces or more, so what you will generate is a polygon. So if you only have two forces, so most likely you will be creating a triangle, because the third side will be the resultant force. So for example, two forces only. So let's say this one is P, this one is Q. So two component forces. So the resultant is the hypotenuse, or let's say the longest side. So that's why it's called the polygon, because of course the triangle is also a polygon. And I think this will be important, this particular technique, because in most four systems is you'll be creating the FBD. So FBD is, I think it's very popular in physics, free body diagram. Okay, so quanta physics ta physics. Mano dyan na siya. So I know you hate physics because that's why you became an architect, but you don't have any choice, because you still need to understand the concept behind statics, because it will be part of your drawing later, drawings or your sketches. So of course, when we design buildings, or when you design later on in your career, so di na tapataka og, so okay ra walay column dire, because it will take up much space. But of course, when you look at your design, so probably your second floor may collapse, or your slab may collapse, because it doesn't have any support. So muna siya ang importance aning a subject. Okay, so to give you a mindset that of course your design may be aesthetically good, but maybe in structural wise, maybe delicate siya nindot, diba? So that's why we work hand in hand with the architect also sa ilang mga drawings. So muna, there's a dispute that architects and engineers are enemies, diba? Kaya marag di sila magkasinabot, and they don't understand the design. So the design may be difficult to implement, especially when you implement diagonal columns, or let's say you have too much cantilever slab or overhanging slab. So those are the problems that you will be meeting in your future career as an architect. Okay, so product of a scalar and vector. So scalar is again the magnitude only. So if you put it with a direction, that's the vector component. So as you can see here, we have f. Then if it's a bigger magnitude, so of course, as what I have told you earlier, the length will also justify the magnitude. So notice that this one is positive. So if we try to reverse the direction, so it becomes negative. So again, try to justify your values with your drawings. So 2f, this one is negative 1.5, so it must be shorter than the 2f. So again, we're not very strict with the exact measurement of your forces, but just try to estimate that the largest value of the force must be larger Jude compared to the other diagrams sa inyong forces. Okay? Okay, so this is what I mentioned earlier. So your different addition of your vector mechanics. So P plus Q is equal to R. So for example, this one is P, this one is Q, then this one is R. So again, since we cannot add up directly your vector forces, so what we'll be using is the different laws in geometry. So we have your sine law. So I hope you mastered this one in your high school or in your senior high, since I think architecture is a part of STEM siguro, so I'm not sure. Then we have cosine law. Okay. So of course, we need to remember the three postulates, but as you can remember in your geometry class, so these are postulates. So we have the ASA, the angle side angle. So this one, the first one is most likely useful in the sine law, because looking at your sine law, so if you have angle side angle, so let's say angle side then angle, so you can solve for one component, right? Now for the second and third one, this will be useful for your cosine law. So side angle side, so this will be the side, this will be the angle, then this will be the side. So as long as, so the side angle side is useful when you want to determine the resultant force, because the angle between the sides is the opposite of what you want to determine. And then the side postulate is important if you want to solve for the angle only. So let's say all the sides are given. So let's say you want to solve this particular angle here. So that's the SSS postulate, and you'll be using the cosine law. So math gyapon, di ba? Math. But not too much mathematics, but just basic mathematics. So I think you have also calculus, no? Sa inyong syllabus, sa inyong curriculum. So not sure if you still have calculus, but as I remember, I taught calculus man siguro before sa Archi. Okay, so again, when we are solving for the resultant, we'll be utilizing sine law and cosine law. So don't be shocked by the polygon katong mga quadrilateral, katong more than three forces, because of course we don't want to make your lives miserable. So katong sa engineering. So ang engineering is more than kuan sila, more than sa triangle na ilang i-solve. Sa inyo siguro, so probably the difficult problem will be katong quadrilateral, katong three forces. Then if you draw it, you'll be having a four-sided polygon. But in most cases, you'll be just be dealing with two forces, because not to look down upon you because archi mo, but of course, this is mo hasol-hasolon kay this is not a major subject to you guys. Okay? So, of course, if we have a right triangle, so solving the resultant force, so let's say this one is P, this one is Q. So the resultant is this one. So to solve the resultant, so let's say P plus Q is equal to R. So what we will be using here, since it's a right triangle, so you'll be using Pythagorean theorem. So super simple, di ba? So Pythagorean theorem ra ato ang gamiton. Okay. So again, the sine law and the cosine law are for triangles that are not right triangles. So it may be scalene triangle, it may be an obtuse triangle. As long as it's not a right triangle, so you have to use the sine law and cosine law. But if it's a right triangle, so our lives are much our lives are easier because we're going to use the Pythagorean theorem. So shout out sa Pythagorean theorem di sa Mokibaw, di ba? So c squared is equal to a squared plus b squared. So c being your hypotenuse. All right. So we have sine law, cosine law for solving the resultant in a non-right triangle force system. Then we have the Pythagorean theorem in a right triangle system, force system. Okay, so let's go to an example. So determine the direction of the resultant of the two forces using A, the parallelogram law, and B, the triangle rule. Okay, so as we can see, we have the force, the 900 newtons having an angle of 30 degrees. Then the 45, and then between your 900 and 600 newton force is it's 45 degrees. Okay, so if you want to draw, so using katong inyong parallelogram law, maglisog litok na. So of course we're going to create the this one. Sayop. Okay. So again, if we're going to, so I think you need your calculator here. So again, if you want to use the head to tail, so that will be your 600. This will be your 900. So again, justify according to your, then connect this one to, this one is your resultant force. Or if you don't want to, so again, the first law, the parallelogram law, so you need to create a, so this one is 600, this one is 900. So create a parallelogram. So this is your resultant force, okay, with respect to the x-axis. So this one is 900, this one is 600, this one is 30, this one is 45 degrees. Okay. So again, when we want to solve this particular force system, so since this one is, we don't have any, I mean, this one is not a right triangle, so you're going to use cosine law. Okay. So looking at the next slide, so if we want to break down the forces, so what the drawing was done here was, so dirita. So in the next slide, the 900 Newton was the first force, and then the second force, the tip to tail method or the head to tail method. This one is the 600. So it's still the same as the parallelogram law. So it just transferred the 600 on the other side para maka-result mo ginana drawing. Okay? Okay, so the first angle is 30, so it's already given. So we don't have any angle for the first angle here in between the resultant and the 900 newtons. But we know this angle, the 135. So why do we know this? So let's try to draw, or let's go to the previous drawing first. Oops, sorry. Okay, so this one is 45, then this one is 30. So if this one is placed here, so we know that the um, going towards 90 degrees, diba? So this one is 90 degrees. So far what the angle has covered is 75 degrees. So 30 plus 45 is 75. So most likely this is the 600 angle here. So napay sobra, di ba? 600 newtons. So napay sobra nga 15 degrees. Okay? So here, if we try to recreate our drawing, ba? So how do you say this? So I think it's kato sa inyong trigon siguro, it's alternating angles. Interior alternating angles are congruent. So if this one is 30, so this one is also 30. Okay? So plus 90, diba? Plus 90, 90 degrees, then plus the remaining 15 degrees here. So that's 30 plus 90 plus 15 degrees. So you have 135 degrees. So that's why you have 135 here. So again, if you are confused on how I got 135, so try to research on alternating um, interior alternating angle. So if you recall your trigo, so di ba naman tayo topic kay nani? So alternating angles are congruent. Interior alternating angles so are congruent, di ba? Then adjacent angles are supplementary, di ba? Then alternating is congruent. Then this one is alternating, so this one is alternating also. And going towards here, it's opposite, so congruent. So I think that's the topic that you need to review in your trigo. Okay, so notice that in our diagram, so with this we have this diagram here. So 900, and then the resultant force here. So 600, then 900, then this one is 135 degrees. So notice since our force diagram is not a right triangle, so we need to utilize sine law or cosine law. Okay, so in sine law, so that's ASA, di ba? So here in our diagram, we have two sides, 900 newtons, 600 newtons. So we cannot use the sine law, but we can use the cosine law. So for cosine law, we're going to utilize the SAS formula or the SAS postulate leading to the cosine law. So SAS postulate, side, angle, side. And again, the opposite of the side is the term um, to be solved for, and that's the resultant force. Okay. Okay, so using the resultant force, so R. So let's try to write the formula. So R is equal to, so if you are an old school nga pag write sa formula, so instead of R, di mo gana maglibog, so you can use C squared is equal to A squared plus B squared minus 2AB cosine theta. So muna siya. So C is the opposite of the angle theta. So that's why the opposite of 135 is the resultant. So with quick um, calculation using the calculator, so what you'll have here is 1391 newtons, or usually in our practice we make this one as kilonewtons. Okay, so of course if you want to determine the angle alpha, so you have to use the sine law. Okay, so to solve for the angle of the resultant, so since we need the angle of alpha, and we have already solved for the resultant force earlier, so you can now use the ASA postulate. Okay, so ASA, so angle, side, angle, and the resultant force. Okay, as long as I think in sine law, I think it's important that you only have one unknown in your sine law. As long as there's one unknown, so you can use the sine law technique. But be careful in using the sine law, because if you're going to use sine law, so I think that's A all over sine A. Then let's make this one small. Sine B, and then C all over cosine naman on sine C. So be careful that, so this one A, B, C. So be mindful that your angle A is opposite the side A. Okay? Angle B is opposite the side B. Then C is opposite. So nag-atbangay na sila. They are facing each other ba? Diba? Okay, so for example, your R here. So the angle facing the R side is 135 degrees. So that's why it's being paired up here. Then 600, the opposite angle of the 600 side is the angle alpha. So that's why they're also paired up. So that's how you use your sine law. Then I think you know how to use your calculator. So getting the angle, so you have 17.8 degrees. So we always refer from the x-axis. That's why the angle of the resultant is 30 plus 17.8, and that's 47.8 degrees. Okay, so do you have questions? So I think murag complicated kaya ang topic, no? Or murag it's just a um, deja vu for your physics subject approach in a different manner. So okay ra so far? So basi nangatog na mo diya kay Holy Hour baron. Okay? So I think wala mo siguro, nangatog na siguro sila eh. Hello, hello. Naraday. Apin ako kuan na nawa na mo. Sige lang, ay kabalaka kay di ra ko kuan, di ra ko terror. So sa mga Arky kay forgiving ako, pero sa amo ang kuan siguro FCE pa ni. So hindi siguro ko forgiving. Di ba? Joke lang. So sige lang, dito mo bombahan og maayo kuan kay. So yan na mo ron, design 2 na mo ron. Design 4. First year pa no? First year. Okay, I think every sem design 2. Okay, as what I have recalled in my brother, okay, every sem is you have design subjects, so design 1, then up until design 10 na siya. But I think, do you have 4-year course now or still 5 years? Sa inyong bagong curriculum, 4 na lang mo no? So probably you will have 5 gyapon mo? Ah, pero design 8 lang mo gotob. Or so 10 na gyapon. Mm, sige, sige. So, sige lang, ato na lang siyang hininayon. Basta, murag ang ako ra siguro ang aim for this semester is for you to understand that um, the force components affects your design later. So, bahala, you will be following the building code or whatever code that you have in your design. Basta as long as basta makarealize mo nga later on, um, dapat you need some adjustments because probably in the implementation process it's difficult or it's impossible that you have this design and so sige lang. Okay, so we have so next is we have concurrent forces. So when two or more forces are said to be concurrent, so meaning their line of action meets at one point. Okay, so for example, you have the block earlier. So let's say you have this force, then you have another force here. Let's say this one is a pulling force, this one is a pushing force. So as you can see, they are concurrent because their line of action meets at one point, diba? So maski ninyo pa na-extend og maayo up until here, so their line of action is the same. So they are concurrent. But in most cases in our discussion later on, so we won't be dealing much with concurrent forces, but we'll be dealing with non-concurrent force but on the same plane. Okay? Because what we're after for is the resultant force, not the component forces. So this is just a review lang of your physics, that there are concurrent forces and non-concurrent forces. So again, the review. So F1 and F2 are non-concurrent. So kaning example nga akong i-draw, so they are concurrent because they meet at a specific, um, I mean their line of action are the same and they meet at a certain point. Okay.